Hello! This video is basically a build log of my external control hub. At the top of the screen you can see that there are several chapters because I've split this video into several parts so you don't have to watch the whole thing if you don't want to. So if you just want to know how I handled a particular area, just click the chapter and it will skip forward to where I covered that particular subject. If not, just continue watching. Now, the purpose of this unit is to provide access to all of the controls and ports that would otherwise be on the computer itself, such as the power button, optical drive, USB ports, card readers, audio connections, and even a hard drive LED. It's connected to the computer by a 5-meter wire, which means that my computer can be in another room where I can't hear it, because I like quiet computing. The computer itself is actually quite special because it's made out of wood. If you'd like to check this out, there's a link to it in the description. The unit itself is mostly made out of 4mm MDF. These two supports you see here support the optical drive, which divides the unit internally into two parts, providing support for the upper electronics. The front is permanently attached to the base, whilst the sides, top and back slide on like a shell. The top latches onto these nuts and bolts to make it really sturdy, and the shell is held in place by screws from the bottom. The MDF has been veneered to make it look like proper hardwood, and oiled as well to give it a nice shine. The top is just hardwood, so that I could get the curved edges by planing then sanding it, which has also been oiled to get that nice shiny look. To make all of the holes and slots in the front of the unit, I basically used hand tools like chisels and files. It's a bit of a fiddly process, but if you put the time in, it's perfectly doable. One of the most important and complex parts of this build was in fact the cable. Because it's quite a specialised use, there aren't any cables that you can buy that would do the job, so what I had to do was make it myself. So I ended up using several different cables and binding them together using a plastic sheathing. It's quite cheap and works quite well. I wanted the unit to turn on and off with the computer, so a perfect source of power is in fact the computer's own power supply. Now, in order to get that power to the unit, I needed really thick wire. Now, this is because over the length of 5 meters, you need thick wire, otherwise the wire won't be able to deliver the power that's required, especially for the optical drive. What I used was audio cable, but any really thick wire would do. Here you can see that I've used 4 strands of it, 2 for the ground and 2 for 5 volts, which is the only voltage that's needed. Another wire I used was a USB 3.0 cable. Amazingly, this was £1 for 5 meters, so a pretty good bargain there. I chose a USB 3.0 cable because it has so many internal wires. It has 2 sets of screened wire and 4 loose wires, and the whole thing is also screened. I used the 2 screened pairs for the USB 2.0 connections, and I used the remaining wires for the power button and hard drive LED. Now, the final wire that I used in the cable is just a screened audio cable. This wire was used to transfer the audio from the computer to the unit without any interference affecting the signal. The audio link is fairly straightforward. At the computer end, the cable plugs into the sound card, and the signal is sent through the screened audio cables I mentioned earlier. Inside the unit, there's a 10-watt amplifier, but because my computer's sound card is powerful enough to drive my passive speakers at a decent volume for most situations, I've built in a power button that turns the amp on and off, whilst also redirecting the audio signal from going directly to the speakers to going through the amplifier first. The amplifier that I've used is an amplifier kit from Maplin. Now, this is the only other device that needs a higher voltage, so what I've done is add a little power socket at the back of the unit, which when I want to use the amplifier, I just need to make sure it's plugged in and off I go. Obviously, I don't want to use the speakers all the time, so I've built in some audio sockets as well. As you can see, there are 3 of them, which allows for various configurations of inputs and outputs. Imagine the audio passing through from left to right. The middle socket cuts the signal if something's plugged into it, muting the speakers, whilst the other 2 silver sockets always allow audio in and out. This means that I can listen to my computer through headphones whilst listening to my MP3 player through the speakers, or both through the headphones, or both through the speakers. You get the idea. All the devices inside the unit work via USB. There are 5 internal devices in total and 4 external USB ports. Connecting each to the computer's USB ports would make the wire too thick, so what I've done is build in 2 4-port USB hubs. These hubs are powered by the computer's 5-volt rail directly, using the thick wire I mentioned in the cable chapter. They're connected to the computer with the 2 screened wire pairs, but not quite directly. In the middle of the wire are 2 USB repeaters splitting the wire into 2 halves. Now these are required for reliable USB data transfer at 5 meters. I know 5 meters is within the USB 2.0 specifications, but I was experiencing errors and bugs at 5 meters on any wire, in fact. It might not happen with you, but it's just worth experimenting before you make your own wire. The reason why USB repeaters solve this problem is because USB cable length gets reset whenever a USB hub is used, and a repeater is basically just a 1-port USB hub. You need to be careful with choosing your USB hubs that you actually use in the unit. I bought 2 fairly expensive hubs and both failed within a space of a couple of months. Ironically, I've replaced them with really cheap Chinese units. They are no branded, but they look like this. There are loads of them on eBay and they're very, very cheap. And these seem to be faring a lot better. The optical drive is a standard optical drive from a laptop. It's got a SATA interface, and I have connected it to one of the USB hubs using a SATA to USB converter. They're about £4 on eBay and reasonably reliable. They're a bit fiddly to connect to the USB hubs though. To save space you have to solder the wires onto the converter directly, which is a bit fiddly, but it is worth it to save the space at the back. Now, as far as I know, you could even build a Blu-ray drive in, and at some point in the future I do plan on building a Blu-ray drive in, but it would be pushing the USB 2.0 spec a bit. There are 2 card readers in the unit. One is a Kingston all-in-one card reader, which is the silver one with the rounded edges. It's fairly cheap and works very well. It's very reliable, and it's just a great unit because it looks quite aesthetically quite nice. The other card reader is a really cheap integral card reader. This one just reads SD cards because that's one of the most used SD card types that I use. And but yeah, both are reliable enough. I've not had any issues, so if you want to use these 2, I heartily recommend them. Again, these are just connected to the USB hubs that I've built in. Now this is one of my favourite bits, the infrared remote. Now I found this on eBay. It's quite a gem actually. It's called an MIII remote, or my emote. Or something like that. It's made in China and it has its own little receiver, and you can program all the buttons to do what you want. You can have media buttons, or you could have Windows media player buttons, or whatever. And it actually programs it into the firmware chip. It was cheap in price, but they've really thought about it as a product. The infrared receiver is just built in under the hard drive LED. It just goes straight into the receiver chip, which works via USB and goes into the USB hubs. And now the microphone, which I'm actually using now to record this video. This was one of the more time-consuming parts of the project. Although it seems simple, I do like fiddling with audio and I wanted to get quite a good result. So obviously, to transfer a microphone signal over a 5-meter cable with all the USB connection interference and stuff going on would not work well. So connecting the microphone via USB rather than an analog connection is really the only way to go. So what I've used for this is the PlayStation 2's SingStar microphone connection, which works via USB and can be connected to any computer as a normal USB audio input. One of the great things about this is that it's stereo, which is quite a rarity, especially for £3, because that's how much it cost. Obviously, this is a line level input, so before the microphone can be plugged in, you need to build an amplifier for it. I used a amplifier kit from Maplin, and I also needed a ground loop isolator, because it works off the same 5 volts that the input is working off, and it created a ground loop. You need to prevent that with a ground loop isolator. And the microphone is homemade as well, actually. It uses an Electret microphone from an old Dell laptop. I'm using this Electret because it sounds brilliant. It sounds way better than any other microphone I've used. So that wraps up the creation of my external control hub. I hope you found this video useful, and I hope you've learnt a few things from it. If you do attempt one of these yourself, please send me a picture of your progress. I'd love to see what you do, and just be creative with it, try your own designs, and have fun. There isn't anything like this you can buy, so if you make one, you can say, "I made that," to your friends, and they'll be like, "Wow." So that's good. If you want to have a look at the other projects I've been working on, please have a look at my channel. If you've enjoyed this video, please give it a thumbs up, and if you have any questions, just leave them in the comments and I will answer them as soon as I can. I'm Matt, and thank you very much for watching.